Okay, so today we're going to talk about finding segment lengths and how you can actually find the lengths on a number line. So I gave you a number line here from -3 to 4, and you have points A, B, C, and D, and they're at different points on a number line. Now, when you are finding the lengths of things, you have to keep in mind like a tape measure or a ruler. And we're going to talk about this ruler postulate in a second, but even up here, if you keep in mind or think about that, it might make it a little bit easier. On a ruler, do you have any negative numbers? On a ruler? No, it starts at 0. On a tape measure, you do not have any negative numbers. So when you are talking about lengths, it's always going to be positive. No matter what, you're counting. When you first learn to count, you go 1, 2, 3, 4. You don't start with negatives or things like that. You're going to be counting on a number line. So, for instance, it says here in example 1, how can you find the length of segment CD? So, segment CD means you're going to count from C to D. So, I go from 1 to 4. So, I go 1, 2, 3. The length of CD is 3. And that's it. Or if you think in your head, how do I go from 1 to 4? What's the distance from 1 to 4 on a number line? 4 minus 1 is 3. So that's another way to do it. 4 minus 1 equals 3, not 4. Down here it says, how can you find the length of AC? So AC, start at A, which is at -3, and count up to C, which is at 1. 1, 2, 3, 4. Or you can go from highest to lowest, or you would go 1 minus -3. And what happens when you subtract a negative? In English and in math, double negatives actually are what? Positives. It's the only time you get some cross-curricular training going on there. So basically, on a number line, you just count. Count up. What's the distance? Or on a number line, what's the distance from this to this? So like, for instance, what if I told you that a totally different problem? X is at -10 and Y is at, let's say 7. What's the length of XY? If on a number line, X is at -10 and Y is at 7, what is the length of that segment XY? What would it be? 17. Because you would start at -10 on a number line, and you'd have to count up to 7. Well, to go from -10 even to 0, we know is 10. And then from 0 to 7, we know is 7. 10 plus 7 is 17. So this is another way that they could give it to you today. They could just tell you where the points are at. It does actually happen today on your worksheet. And then you would have to just find the distance or the length between them. Does that make sense? Kind of, sort of. That's what the ruler postulate is. The ruler postulate basically tells you that even if the coordinate is at -10 and the coordinate or the point is at 7, you are measuring. So on a number line, you are measuring how far apart points are. Which means that if you are measuring, it is always a positive number. Make sense? It's probably the easiest thing you'll do in here. Count up. If you can count, you can find the lengths of segments on a number line. Easiest thing. All right, flip the page, and I want you to try example 2, we're going to skip the top part there, but I want you to try example 2, part A, B, and C on your own. I want you to find the length of those segments. They didn't put the little segment mark over it, which I'm not happy about, but find the length of those segments. So from K to L, you go from 12 to 16. And if you count, you go 1, 2, 3, 4. Or if you go 16 minus 12, it's 4. Any questions on that? JK goes from 5 to 12. If you count up from 5 to 12, or if you do the biggest minus the smallest, so 12 minus 5, you get 7. And then from K to M, I don't know about you, but I wouldn't want to, well, I mean, I guess you could count all of that. But if you do the biggest minus the smallest, 27 minus 12, you do get 15. So any questions on example 2? It's the first half of what you're going to do today. You thought math class was going to be hard today, right? Takes a bit of a turn right now. Just a little. Okay, so we've got to start adding in some variables, and that's where this segment addition postulate kind of pops in. And if anything's going to be hard today, this is going to be it. So just as a warning. So what the segment addition postulate says is that, like on a ruler, if I found the length from A to B, so if I found the length from A to B, and then I found the length from B to C, and let's say I add those two lengths together. So if I take the length from AB, whatever that length is, and the length from B to C, if I add them together, that gives me the length of what segment? If I take AB plus BC, what segment length does that actually give me? From A to C. So like, let me show you with numbers. If I gave you, if I had this is A, this is B, and this is C on a segment. If I told you that the length from A to B was 2, and the length from B to C was 8, and then I asked you, well, if you know that, what's the length from A to C? You would just take the length from A to B plus the length from B to C, add them together, and the length from A to C, that entire length would be a length of 10. Does that make sense? What's also going to happen is they may give you like one of the links and the whole length and want you to find one of the little missing links. That could happen as well today. Like they could give you, I'm just going to keep doing my own little examples here. Trying to think ahead of what's coming up on like quizzes and tests. So if this is X, Y, and Z, if X, Y is 5 and XZ has a length of 23, what's the length of YZ? So how would we do that? If XY has a length of 5, and then the length from X to Z, so that means this entire length from here all the way over, that's the big guy right there. If that's 23, how do I find the length from Y to Z? Like this is like your unknown right here. Subtract them. Take the big number minus the small number, 23 minus 5, and you get that the length is 18. So that's another thing that you could have to do today. Does that make sense? Yes? Okay. I don't like this example very much. We're going to come back to it. I don't want to start you off with that example, I should say. So flip the page and let's look at this triad. This says 3n and this says 5n minus 7. The variables are back. I know you missed them since last year. Right? Everybody missed them a little bit. No, not so much. So this triad is very similar to really what we're going to have you do. You have to remember this year that you're in geometry, not algebra. So and you're going to hear me say that a lot, yes, you're going to solve for variables, but you're most likely, because it's geometry, you're going to use those variables to actually plug in and find links. And this try it kind of gets you going with that. Most likely, if you solve for a variable, you're going to have to plug it back in. And that's kind of the progression from algebra to geometry. So if we take a look here in the directions, and you have to read. I know a lot of us don't like to read directions. I'm not a big read direction person. I like to look for the bullet points and the important stuff. Sadly, a lot of the important stuff is actually in the directions. So they tell us here that J, K, and L are collinear, which collinear means that they're all in the same line. And then here it says, if JL equals 25, what is N? So JL, all the way from here to here, that's the large segment. That equals 25. And then they want us to solve for N. So JL is the big guy, and then there's two little guys that make up that 25. So how would we solve for N? Thinking about what we did before when we didn't have variables. What do we know? How can we do this?
Subtract.
What am I going to subtract? I would subtract if I need it, I'm solving for a variable. So not like last time we subtracted to find just like one little piece. What do I know about JK and KL? If I add JK and KL together, does that give me the 25? Because it's the two small pieces. So you're going to take these two small pieces, JK and KL. When I add them together, that gives me the entire length of JL. So I'm kind of setting up a little algebra problem here. This is your segment addition postulate. This little length plus this little length gives me the big length. That's what that says. So now what I'm going to do is from my problem here, I'm going to substitute whatever JK, KL, and JL are in for my little equation here to set it up. So JK, that length is 3N, plus KL is 5N minus 7, and that equals JL, which is the entire length, which is 25. So basically you take the two small segments that make up the big segment, the two small ones, you're going to add them together and set it equal to the big segment. All right, so we have this algebra problem right here. Now you're just going to use some of your amazing algebra skills. What do we do first to solve this algebra problem? Yes. Yes, combine like terms. We have a 3n and a 5n. 3 plus 5 is 8. So you have 8n minus 7 equals 25. Now you have a two-step equation that you would have learned pretty much on this exact day last year in algebra, because this is what they're doing. So to solve this, now what do we do? Yeah.
You would take the minus 7 and do plus 7 to both sides to cancel out the 7.
Perfect. Add 7, so then you get 8n equals 25 plus 7 is 32. And then your last step is to divide both sides by 8. And you get n to equal 32 divided by 8 is 4. But this is what I mean, like you're going to solve for a variable, but then there's always going to be a second part here. And I kind of gave you a hint in your notes. We solved for n, got n to equal 4, and now we need to actually plug it back in. So keep in mind that how we did this with JK, 3n, KL, 5n minus 7, if I combine these together, that gives me the entire length. So now to plug it in, I need to find the length of JK, and I need to find the length of KL. JK is 3n,